Hello, welcome to Helidon Screencast. Today we will take a look at the examples of connecting to Kafka with new reactive messaging features. So let's go to our main repo on the GitHub. If you will check out the master branch, you will find folder examples here, and in examples there is folder messaging. In the messaging there is a readme describing how to start your local testing Kafka server instance for running the examples. It's quite straightforward. I have opened it here already, so we will just run it. Kafka run. Okay, looks like it's up. Let's get in another window. Examples, messaging again. And there are two projects. One in Helidon MP and one in Helidon SE. So you can see both flavors working with reactive messaging. The examples are using WebSockets to propagate the push events to the client. So we will see some demo. We can start with the MP flavor, which is following the microprofile reactive messaging specification. So how does it look? Yeah, we have a resource. Start from it. Over which we can send the message actually to our messaging and to the Kafka later. So it's simple get. We will get message and sending to the messaging bean. Messaging bean is being injected by CDI. The messaging bean is using the microprofile messaging. You can see it here, outgoing methods, some processor, incoming method, and so on. We are using the submission publishers for emitting and broadcasting because it can solve the back pressure for us in our example. It has a buffering in it and it's packed in the Java already. So we are using the publisher as an emitter, so publishing to the stream manually by the send method we have seen already. That's the process here. It will submit to the submission publisher we called emitter. The emitter is used as a publisher for a channel called multiply variants. Multiply variants is connected to the is just a processor which is doing the flatmap. It's multiplying the message to 3 standalone messages. One of them is in uppercase, one of them is repeated twice, and the last one has reversed characters, so we can see it's doing something. Then it's being wrapped to the message, and it's sent to the channel called to Kafka. As we can guess, to Kafka is connected to the connector itself. We have simple properties configuration here of the messaging. This is the configuration notation of the microprofile reactive messaging specification. And we can see there is a channel to Kafka directed to the connector Helidon Kafka. This means actually that it will create new subscriber which will send it to the Kafka for us. The connector will get some configuration. It's all here. There is where is Kafka, what's the name of the topic, and what serializers and deserializers used. Those properties are common for all the channels that will request creating publisher or subscriber from the connector, and those are actually special properties used only for for the channels, so we can see the difference here. It's all getting merged in the end, and so the connector can use auto-config it gets. Okay, this is how we send to the Kafka. We do some transforming, so it's nice. And then we will listen from the Kafka. We have a WebSocket endpoint here. There is another article on Medium about WebSockets. Take a look at it, it's nice. But we will use only WebSockets for pushing the events to the client. Last time we did it with server sent events. This is a different approach again, with same result in the end. So we won't be waiting for any messages from the client. We will be just pushing, so there is no back pressure applied. We will be when the client registers the WebSocket, we will subscribe our processing bean, and the subscribe multi will return our multi. That's reactive stream, so we will check some errors if some comes, so we don't lose it, and we will request unbounded number of items by using for each, and on every item that will come from Kafka, we will send the text message with the WebSockets. It's somewhere here. Yeah, we are sending in the session of the WebSockets simple text message. That's how the WebSockets is used. We will take a look at the subscribe multi. This is a multi which is this is a reactive stream created from a publisher which is called Broadcaster. Broadcaster is used for listening for events from the Kafka, and submission publisher can take more than one subscriber, so it's ideal for our use case of broadcasting to multiple subscribed WebSocket clients. So here's the method of the reactive messaging, which is actually listening the messaging from Kafka. So you can see again in the configuration, there is a from Kafka configured, there is a name of the connector, there is enable auto commit. We don't want to solve it in this simple example manually, and there is a group ID. That means that in the same group ID it will work as it should. So we can try to run it. There is a simple client which will connect to the WebSocket. We can take a look at it too. There's an index file. There's some JavaScript connecting to the WebSocket. You can see it here. And when the message comes from the server, we will run some animation, show the data, and log it. So let's run it. Not here, of course. Okay. Kafka WebSocket MP. We will use the Helidon CLI feature, which is quite nice. Helidon dev mode. Yeah, it's actually running Maven, but it has some features, so we don't have to reload it every time we change something. It's starting already. Yeah. So let's take a look. The localhost is 7001, and we will send some message. So hello screencast MP. Send, and we see that the 3 messages actually went through the Kafka. One of them has reversed letters, one of them is twice as long, and one of them is in uppercase. That's exactly what we did in the messaging. We can take a look again to our messaging bean. Yes, there is a flatmap, and it's doing the uppercase variant, repeat twice variant, and the reverse characters variant. So that's the MP. You have already saw that in the latest screencast with the servers and events. So we will try the same thing, but with the Helidon SE. We have our own API for the reactive messaging there, because there is no CDI, therefore the specification variant wouldn't work there. But the connectors in Helidon are designed that way that they are usable in the both flavors. So we will take a look right away. Yeah, it's again WebSockets, this time in Helidon SE, reactive messaging. We are doing broadcasting a little differently, so we can show some other approach. There is a sending service again. We have to get method somewhere here. Yeah, there it is. When it started, it's connected to Kafka, so we can send to Kafka actually. This is the API of the SE messaging. As you can see, we are using explicit configuration. It can do even the microprofile reactive messaging configuration notation, but we can use our own config. We have a config builder in our Kafka connector, so we can explicitly configure messaging in the code, or use the standard notation for the reactive messaging defined by microprofile. So here we are configuring the Kafka server from the config. We have it somewhere here. Yeah, there is a topic and bootstrap servers. This is a custom configuration. We define the serializers. Then we prepare the channel. We have some processor here, so we have a channel to processor. We have a channel, we have a connector to Kafka. Connector to Kafka, you can actually instantiate that only once, then it can create the publishers and subscribers for channels indefinitely. And we prepare the emitter. We don't have to use the submission publisher here, because reactive messaging in Helidon SE has its emitter for that. It's somehow wrapped submission publisher in the end, but it works very similar with some bonus features. We will register our emitter. The emitter knows he should send into the two processor channel, and we will register processor, which will be acting as a subscriber for a two processor channel and as a publisher to the two Kafka channel. And we will register the Kafka connector, and Kafka connector will recognize that as a subscriber it should use as a subscriber for the two Kafka channel. You should create a subscriber, and then we will build and start the messaging. The processor is doing only two uppercase, so there is no flatmap here. We will send only one message to the Kafka, and it will be in uppercase. It's for the simplicity. We can do the flatmap later here also. So this is the sending message. There is a get method registered. Again, we have a message as the path param, and then it's sent right to the emitter and through our messaging to Kafka. All configuration for Kafka is here. We can see it actually in one snippet of the code. No magic involved anywhere. And then we have again WebSocket endpoint, this time without annotations, because we are in the Helidon SE. When the client is opening the sessions, this time we will try something different. We will actually open new connection to Kafka every time that the client is connecting to the server. So we can see that the Kafka itself can act as a broadcaster. It will working as a topic. For that we need to have a unique group ID, so the messages are not split among the subscribers. And to have unique group ID, we will use the session ID, which should be always unique for the WebSocket. Again, we have explicit configuration here for the from Kafka. We are building channels again. We have a channel. The channel has a name in case we want to configure something special in the configuration. And then we have a connector again. Only one should be enough. We can create more of them. It's reentrant, it shouldn't be a problem. We will build our messaging. We will register the connector. We will register a listener. Listener is a special subscriber for the messaging, because it's doing the unwrapping from the message wrapper automatically, and it's doing acknowledgement automatically. It's the only magical thing here. It's so the readability is easier. So if you are not using the wrapping and acknowledgement, it's easier to use just a listener to listen from the messages from Kafka. So we have just a simple lambda here consuming the Kafka payload coming from the Kafka and sending it again over the WebSocket. This is the same like in the MP example. And on close, of course, we have to stop the messaging. So when the client disconnects, we have registered our instance of messaging in the map with the key of the session ID. So when the session is ended, we can safely close the messaging. The stop actually delegates the stop method from the connector, so the Kafka client is properly stopped. That's always a good practice to do. And we have seen how we are listening to the Kafka. We have seen how we are sending to the Kafka. So we can actually run it, right? We will go again, this time into the Kafka WebSocket SE example, and we will use the CLI for running it in dev mode. It's just super nice. It's building by Maven. It's also listening for the changes in the source code. So if you are changing something, it will reload the app, and we are good to go again. So it runs. We will do the hello screencast SE again. We will do the send, and we got the uppercase. It went through the Kafka, and the messages is received. We can see that every time we are opening the session, we are connecting to Kafka again. We can use Firefox for that. So it's nicely visible. We will connect to the same server. Hi from Firefox. And we can see we have received the message through the Kafka. The Kafka is acting as a broadcaster here, so the Kafka has broadcasted to the different subscriptions for us. So this is the example. We can try to add the flatmap thing here. So we have a WebSocket which is listening. We don't have a processor here, we have it in the sending service, right? It's here. There's a payload. We will use different kind of processor. We use reactive one. So reactive streams API builder. We can unpack the message wrapper first, so it's nicer. Message payload, yeah, get payload. It's done. This is nicer. We'll use flatmap. We have the payload now, so we can play with the payload. We can create reactive streams of. We will do the to uppercase. Yeah, I know what's wrong. We don't have a type here. That's because of the streams builder. We have the message which will have payload of type string in here. Yeah. Now the type is okay. We will do one uppercase and we will do one lowercase. To lowercase. Yeah, this is the flat map. And then we will wrap it again for the messaging, because this is Helidon SE, no magic involved. So if we are working with the streams, we always have to work with the message wrapper. That's so nobody gets confused that something is done automatically. So we will do map again. We will do simple message off. We have automatic offset commit, so we don't need to take care of the acknowledgement. And that should be all. So the dev mode should reload. When we save the changes, it's done. Reload for sure. We will try flatmap. And we can see there is a try flatmap in lowercase and try flatmap in uppercase. So that's all I want to show you today. Don't hesitate to try it for yourself. We have some more documentation about reactive messaging, and there will be more articles and more videos coming, so stay subscribed to the Helidon channel. Goodbye.